Alright, so I want to go over the questions that we did in class today. So these are on page 379. Okay, they're page 379, and it's numbers 31 through 35. So these are the questions that we're doing in class today. I just want to go over 34 and 35. Those are the ones that actually required a little bit of math. So in order to do these questions, you need to have your 4 steps written down. These are the 4 steps that we copied into our notes, and then the 4 steps that are on the board. So first, step 1, you're going to balance the equation. If you're not given an equation, you may have to write the equation based on the reactants and the products, or the equation might be balanced for you. A good way to know if an equation is already balanced is to check for coefficients. If there's coefficients already in the equation, okay, 2, 3, and in this case 1, then you don't have to do any balancing. You can just move on to step 2. Step 2 is convert grams of reactant to moles of reactant. In order to do this, you have to use the molar mass of the reactant. Okay, remember molar mass comes from your periodic table. Okay, the decimal number on the periodic table, that's your molar mass. In order to get the molar mass of a compound, you can add the molar masses of its elements. Okay? Step 3 is to convert moles of reactant to moles of product. Okay? In order to do this, you have to use the mole ratio, which comes from the coefficients of the balanced equation. Step 4 is to convert moles of product to grams of product. In order to do this, you have to use the molar mass of the product. If you don't have these notes or these steps written down, I highly recommend you pause the video and get these into your notes. Okay, so we're going to use these steps, and we're going to continue to refer to these steps throughout the questions 34 and 35. Alright, so the first one. Step 1 is to balance the equation. As we said, this equation is already balanced. So what we're going to do is we're going to set up something that looks like this. Okay, this is very similar to the dimensional analysis that we've been doing. This is just kind of a different way to look at it. Every time you add a new step, you add a new line. This means to multiply whatever's on top and divide whatever's on bottom. Okay, so step 2, right, step 1 is already finished. Step 2 is to convert grams of reactant to moles of reactant. We know that iron is our reactant because it's over here on the reactant side of our equation. Okay, so we have 83.77 grams of iron. In order to convert it to moles of iron, we're going to use want over have, right? Want over have. We have grams of Fe. We want moles of Fe. Okay, grams per mole or moles per gram. This is molar mass. So we go to our periodic table. We look at iron, and we see that the molar mass is 55.845. Okay, so we're going to put that right in here, 55.85. We'll round it to two digits. Okay, and it's always 1 mole. So that's step 2. Step 3 is to convert, so our grams cancel, we're left with moles of Fe. So then we go to step 3, convert moles of reactant to moles of product. So we want moles, we have moles. So we're going to add another step. We have moles of Fe. We want moles of product. And in this case, our product is Fe2S3. So we want moles Fe2S3. Okay? In order to do that, according to our steps, we have to use the mole ratio, which are the coefficients from the balanced equation. So the coefficient for Fe is 2. The coefficient for Fe2S3 is 1. That's step 3. Now we're going to use another set, and we're going to go on to step 4. We're going to convert moles of product to grams of product. Okay? We want grams. We have moles, so have moles of Fe2S3. We want grams of Fe2S3. Okay, so moles of Fe cancels with moles of Fe. moles of Fe2S3 cancels with moles of Fe2S3. So now we have to find the molar mass of Fe2S3. Okay, the molar mass of iron, as we said, was, let me turn this on, 55.85. We have two of them, right? Fe2. We're going to add that to sulfur. If we go to our periodic table, sulfur is 32, and we have S3 times 3. And we get 207.7 grams per mole. So in here we put 207.7 grams per 1 mole. And to solve this, go down here, we're going to put 83.77 times 1 and 1, we don't matter, times 207.7. We're going to divide that by 55.85 times 2. Okay, make sure you have parentheses so that you keep everything on top with the things on top and everything on bottom with the things on bottom. Okay, so we're dividing our answer for the top by our answer for the bottom, and we get 155.76. So 155.8, and our units are grams Fe2S3. Okay? So if we go on and look at our next question, okay, this one's a little more difficult because instead of giving us a question, it gives us experimental data. So if we look in the actual question of 35, it says to calculate the percent yield of the reaction of magnesium with excess oxygen. So we are looking for overall to calculate the percent yield. Okay, in order to get the percent yield, we have to get two things. We have to get the theoretical yield, and we have to know the actual yield. Okay? And we have to know the actual yield. So we have to, in this question, we have to know that percent yield is equal to the actual divided by the theoretical. Okay? The actual yield can be determined from the data. Okay? The yield is how much product we can make. Okay, so we're making magnesium oxide. The empty crucible, a crucible, remember, is just a container. So when we did the gold pennies lab, we used a crucible, that ceramic container, to hold the pennies while we heated them. So the crucible and the crucible plus the magnesium, or magnesium oxide. So we can get the mass of just the magnesium oxide simply by subtraction. 39.15 minus 35.67. Okay, so our actual yield for this problem is going to be 3.48. Remember to keep your units grams. 3.48 grams. The theoretical yield is what we've been calculating this whole time using our 4 steps. Okay, now we're just giving a name to the calculations that we've been doing. So these calculations are theoretical yield. It's how much can we technically make if everything goes 100%. So, in order to do a theoretical yield, you first have to know how much magnesium you're putting in. Right? How much magnesium is going into the equation to make your magnesium oxide. we have our data that tells us the mass of the crucible plus the magnesium. So again, we do some math. Magnesium is going to be equal to the magnesium plus the crucible minus the empty crucible. So we do 38.06 minus 35.67. Okay, and we get the mass of magnesium is 2.39 grams. So that's how much 2.39 grams of magnesium is what's going into the equation, and that's where we start to build our dimensional analysis problem. Just like we did above, from now here, we can actually continue on with our steps. So step 1, balance the equation. It's already balanced. We have coefficients. So this equation is already balanced. We'll move on to step 2. Convert grams of reactant to moles of reactant. Okay? If you didn't know to use this data to find your grams of magnesium, we know that this is a percent yield problem, which means we need the theoretical yield. This is all stoichiometry, which means you have to follow these 4 steps. So even if you didn't know theoretical yield meant that you needed, or what you needed to do with this data, we know that we need a starting point. We need grams of reactant to start, which means you can use this data to figure out your reactant. Okay? So grams of magnesium is here, which means it has to go down here so that we can cancel out grams of magnesium. We're going to use want over have. Okay? We have grams of reactant. We want moles of reactant. So we're going to put moles, and our reactant is magnesium, Mg. Okay, if we look on our periodic table, the molar mass of magnesium is 24.3. So 24.3 here, and 1 mole. Okay, that's step 2. We're going to close off our this part of the equation and start step 3. Whoops. So step 3 is convert moles of reactants to moles of products. Okay, we have to use the mole ratio or the coefficients from the equation. So we're going to go ahead and elongate here for step 3. We have moles of magnesium. We want moles of product. Our product in this case is MgO, magnesium oxide. We have to use the mole ratio, the coefficients from the equation. So magnesium is going to come from this 2 here. Magnesium oxide is going to come here, 2. So the ratio is actually 1 to 1, or in this case 2 to 2. But we need this to convert our units. In chemistry, we care more about the units than the absolute numbers. Okay, so we have moles of magnesium. Our whole thing is filled in, so we're going to close this off and create room for step 4. Step 4 is to convert moles of product to grams of product. So we have product here. We have moles of product, magnesium oxide. We want grams of product, which is magnesium oxide. Now we have to find the molar mass of magnesium oxide. So we go to our periodic table. We know magnesium is 24.305. We find oxygen, which is 15.999. We're going to make our lives easy and round it to 16. So we're going to do 24.3 plus 16 to give us our 40.3. So grams is 40.3. And our moles is going to be 1. And that is all 4 steps. So we cancel out moles of magnesium oxide with moles of magnesium oxide. All we have left is grams of magnesium oxide, which is exactly what we want because that is our theoretical yield. Okay? Theoretical yield, we're going to plug this into our calculator. Where can I set this? There we go. Maybe down here? Maybe. 2.39 times 2 times 40.3. Okay, all I did is everything across the top. That gives us an answer. There. Nope. Then we're going to divide that by 24.3 times 2. Okay, everything across the bottom. And that gives us an answer of 3.96. 3.96, and our units are grams of magnesium oxide. Okay, that is our theoretical 3.96 grams. That is our theoretical yield. Notice that when we talk about yield, it's always in grams. That's the biggest difference between what's the amount of product made and what's the yield. The yield is always in grams. Okay, so now we're not done just yet because we have to calculate the percent yield. So as you know from your notes, percent yield is equal to the actual divided by the theoretical times 100. Okay, so if we do this, our actual yield is 3.48 grams divided by 3.96 grams times 100, and our actual yield is 88%. Okay? So whenever you're doing a stoichiometry problem, and on the test on Tuesday, when you're doing stoichiometry problems, you need to know these 4 steps. Every single problem, you follow these steps. If your reactants are already in moles, you skip a step. If your equation is already balanced, you skip a step. Okay? If it's asking for products in moles, you can skip this step. But you have to be able to know the steps and follow the steps to get you all the way through stoichiometry. Okay?